The EndoCut from Erbe is an advanced electrosurgical mode for endoscopic cutting. What makes it special is its spark recognition technology and that it can be adjusted individually in several ways. In this webcast, I will show you how it works and how EndoCut can help you overcome some of the typical technical difficulties in various endoscopic procedures. So, become a master user of the VIO units and learn all the technical details about this special mode in this video. EndoCut is only available with the VIO electrosurgical units from Erbe. There are two variants, EndoCut Q and EndoCut I. Both are very similar, however, EndoCut Q is typically engineered and optimized for snare electrodes, and EndoCut I is specifically designed for needle knives and papillotomes. One of the difficulties with endoscopic applications is the risk of perforation if the cut becomes too deep or too sharp. Therefore, when you use the yellow foot switch for cutting, you will usually want to tap it only very shortly. But sometimes the cutting effect can be delayed, and then it can become a struggle to achieve the appropriate incision without too much thermal damage. The blue foot switch activates the selected coagulation mode and typically serves to treat possible bleeding. Prior to EndoCut, it was quite common for users to activate the yellow and blue foot switch alternatingly as quickly as possible. EndoCut not only helps to simplify this difficult procedure, but can also help to have a better control than by tapping the foot switch. Let me give you an insight in why electrosurgical cutting sometimes can be difficult and what makes the EndoCut technology so special. EndoCut is a monopolar mode, which means that you conduct high-frequency alternating current between the active and the neutral electrode through the patient. The current serves to heat the tissue at the point of contact, where the current density becomes extremely high. For cutting, you need very high temperatures of several hundred degrees. For such high temperatures, the contact surface of the electrode itself is by far too big to create sufficiently high current density. The required high current density comes from an additional effect. When you activate the instrument, you can often observe a spark formation between the electrode and the tissue. Now, these sparks are also electrical conductors, like the electrode, but they are much thinner. Therefore, they can develop an extremely high current density. This is how the temperature can become hot enough to vaporize the tissue at the point of contact. This explains why spark formation is essential and actually required for electrosurgical cutting. Beside other factors, the spark formation mostly depends on the electrical voltage and the electrical resistance. The voltage can be understood as the electric force that generates the electric current. It also causes an ionization of the air or gas around the electrode. This actually is the reason for the spark formation. And this is basically what the electrosurgical unit is for. When you press the foot switch, it will apply this voltage. Now, the higher the voltage, the stronger the sparks will become. When you press the yellow foot switch for cutting, this can easily be some 500 volts or even higher. Depending on the selected mode, usually when the voltage is increased, the sparks become stronger. The stronger sparks will vaporize more tissue, resulting in a sharper cut and a wider coagulation seam, and also resulting in an intensified hemostatic effect. As I mentioned before, the spark formation also depends on the electric resistance at the point of contact. If the resistance is very low, the current can easily flow between the electrode and the tissue without producing any spark. Sparks will only develop when the resistance and the voltage are both high enough. The resistance itself depends on the conductivity of the tissue and on the diameter of the contact surface. This explains a typical phenomenon, especially with snares, where the contact surface is rather big. The resistance is therefore often too low for an instant spark formation, and the cut can therefore be noticeably and sometimes even annoyingly delayed. As you can imagine, this can also be a safety concern. So, this is what you will often observe. You activate the instrument, the high voltage will produce electric current, the current will heat up the tissue will coagulate and desiccate, and thereby becomes less conductive, and the resistance steadily rises. And then, in the very instant when the resistance is just high enough, the sparks start to develop, and only now the electric cutting begins. The bigger the contact surface is, the longer this process takes. This explains why the incision on a larger polyp can be more difficult and delayed in comparison to a smaller polyp. Another reason for a delayed spark formation can be if you squeeze the polyp with a snare, because then the wire is completely embedded in the tissue and the contact surface therefore is even bigger. The typical outcome is that it now takes even longer. It wouldn't be such a big deal if it would just slow down the process for a couple of seconds. The problem is rather that in this situation the current will continuously coagulate and coagulate until eventually the coagulation might become too much before the actual cutting has even begun. On the other hand, whenever the contact has a small contact surface, the spark formation can be achieved almost instantly and easier and faster than with a snare, for instance. Let me explain the problem with another graph. The scale on the left shows the voltage that is applied by the generator. Here, the dark yellow phases represent the cut and the light yellow phases the preceding coagulating tissue effect. If you press too long, you might cut too deep and risk a perforation. But it can be difficult to carefully control the cut just with a foot switch. In particular, because the desiccation lets the electrical conditions change during the procedure or the process. Typically, with every activation cycle, the sparks develop sooner and sooner, and you will therefore try to tap shorter and shorter to prevent that the cut becomes too sharp. Therefore, the EndoCut is designed to let you press the foot switch continuously, and it automatically controls the cutting duration and the tapping for you. As you see in the graph, the dark yellow cutting duration phases are not only shorter, but also constant. This is ensured by the EndoCut's spark recognition. You can set the cutting duration, the cutting interval, and the coagulation intensity individually, as I will show you later on. Note that the time it takes to develop the sparks can vary. With the example of a snare instrument, typically this light yellow initial phase becomes shorter and shorter with each cycle, but depending on the changing electrical conditions during the procedure, sometimes it may also become a bit longer again. EndoCut Q and EndoCut I were already available with the Vio D and S series. With the Vio 3, Erbe has improved this technology further. The Vio 3's spark recognition algorithm now uses 25 million measuring cycles per second to detect the very instant when the sparks start to form, even more precisely than before. Now, let me show you the EndoCut procedure step by step, for example with an endoscopy snare. First, you carefully position the snare without squeezing the polyp. Then, gently lift it up to have a distance to the intestinal wall. Be careful to hold the snare in parallel to the intestinal wall and do not grasp too deep, as this could result in a perforation. Then you start the activation by continuously pressing the yellow foot switch. The EndoCut will start with the cutting voltage and hold it until the Vio recognizes the spark. During this phase, the tissue heats up, coagulates, and becomes less conductive. We call this phase the initial cutting phase. This phase continues until the resistance is high enough, the sparks form, and now the electrical cutting begins. The EndoCut automatically holds the cutting voltage for the exact timing that you have set with the selectable cutting duration, which is in the range of a couple of milliseconds. So that is really very, very short. Much shorter than you could ever step off the foot switch by yourself. Vio lets you know when it recognizes the sparks with a short beep sound. Depending on the effect setting that you have selected, EndoCut then either makes a pause or continues with an additional coagulation to increase the hemostatic effect. Then the second cutting cycle begins. Again, first resulting in a coagulating tissue effect. Note that the first sparks form a little sooner now, because the tissue is already more desiccated than in the beginning. Again, only when the sparks start to form, the cutting begins. And again, indicated by a little beep. This process is repeated as long as you press the yellow foot switch. In this example, altogether it took just 3 cycles to resect the polyp. Could be fewer, could be more, very much depending on the individual situation. In the little graph in the left corner, you will have noticed that the cutting voltage is rising incrementally, starting with 600 volts, then 700, and with the third and following cycles it becomes 800 volts. The lower voltage of the first cycles serves to prevent that the effect is too strong for a small polyp. This also explains why it is advisable to keep the foot switch pressed continuously. Because when you tap the foot switch, you will always start again with the first cycle that has only 600 volts. This would result in a less strong cut and would make EndoCut Q less effective. In particular when you use it with a snare on a medium or larger sized polyp, for example. There are 3 settings to select from: the effect, the cutting duration, and the cutting interval. The effect has an impact on the degree of hemostasis. Note that it does not serve to increase or decrease the cutting sharpness. The effect number is about the coagulation in between the cutting cycles. Effect 1 does not add any additional coagulation. Effect 2 adds a little more coagulation to the procedure. Effect 3 intensifies the hemostasis even more, and with effect 4, you receive the most intensive hemostatic effect. Now, the cutting duration is about the sharpness of the cut. It will make the cut more or less sharp by extending or shortening the dark yellow phase. That's the phase during which the sparks are formed. There are 4 values to select from. The 1 is the shortest, 2 is a bit longer, 3 is again a bit longer, and 4 is the longest cutting duration, resulting in the sharpest cut. The cutting interval lets you speed up or slow down the course of the process. There are 10 increments. You can accelerate the process with low cutting interval numbers. Higher numbers will slow it down. As a starting point, cutting interval 6 is a common setting for an endoscopy snare, just as an example. The higher interval settings are less often used, as it all becomes quite slow then. And finally, the 10 is the maximum cutting interval. As shown, EndoCut Q is great for snares and other applications with relatively large contact surface. For instruments and applications with small contact surface and small tips, such as a needle knife and papillotomes, the other variant, EndoCut I, can be beneficial. For instance, for the Erbe hybrid knife I-type. EndoCut I uses 700 volts for cutting, so a little less than EndoCut Q. Also note that EndoCut I does not have an incremental start. The first cut cycle has the same voltage as all the following cycles. If you look at the EndoCut Q for comparison once again, the difference in voltage becomes noticeable. EndoCut Q starts with 600 volts and continues with the higher 800 volts only from the third cycle onwards, whereas EndoCut I starts immediately with 700 volts and not with 600 volts. So the first cycle is slightly stronger, but the later ones are a bit lower than with the EndoCut Q. The cutting interval and cutting duration settings are similar to those of EndoCut Q. The effect settings for the additional hemostasis are a little weaker though. Just as with EndoCut Q, effect 1 on EndoCut I is without additional coagulation phases in between the cutting cycles. But the increase is less pronounced with effect 3 and 4. Effect 3 and 4 just have a different waveform. As you see, EndoCut is a truly advanced electrosurgical mode, specifically designed for endoscopic applications that make use of Erbe's renowned spark recognition technology to help you to power your performance. For further information, please visit our website erbe-med.com or our video platform medical-videos.com, where you will find several videos about EndoCut in use. And if you are interested in learning more about electrosurgery in general and the required safety measures, you are invited to attend our online trainings or e-learning courses on our learning platform www.academy.erbe-med.com. Thank you very much for tuning in and stay safe.